In this video, we're going to look at the alternating series test. We're going to look at a couple examples. So the alternating series test says the alternating series, shown represented here, converges provided that these two conditions are met. So the first condition is that the terms of the series are non-increasing in magnitude. So non-increasing is saying that each term is less than or equal to the term before it. That's the non-increasing. Doesn't necessarily have to be decreasing. It just has to be less than or equal to. And you'll notice that these terms here are greater than 0. So that's speaking to the fact that we're using the term magnitude here. Magnitude is basically referring to the absolute value of these terms. Because it's alternating, we're going to have positive and negative terms. But because it says magnitude, we're just going to look at the absolute value of those terms. And this says for k greater than some index n. And you might end up with some, this doesn't happen very often, but it is possible that your terms are not meeting this criteria for the first few terms, but then at some point, k greater than some n, at some point we do get this pattern of non-increasing, then we could apply this also. You don't see that too often. The second condition is that the limit as k approaches infinity of a sub k is equal to 0. And the a sub k here is this, oops, we don't want that, let's use the highlighter. This sequence here, which is looking at your alternating sequence without the factor of -1 to the k plus 1, so without the changing of signs from positive to negative. All right, so let's look at this example here. Does the sum from n equals 1 to infinity of -1 to the n plus 1 times n e to the negative n converge? So first thing we notice is, yeah, this is an alternating series because we have this -1 to the n plus 1. That tells me it's alternating. So I can apply the alternating series test and see if we get any results. So the first thing we want to do is we want to make sure that the terms of the series are non-increasing in magnitude. So we're talking about magnitude again. We're basically ignoring the fact that they're changing signs. So we can look at the terms of this guy right here and see if those are non-increasing. So let's look at the first few terms and see what happens. So starting at n equals 1, we're going to get 1 times e to the -1. And then we're going to get 2 e to the -2, 3 e to the -3, etc. All right, so we got 1 over e, 2 over e squared, 3 over e to the 3rd, etc. So both the numerator and the denominator are increasing, but we can see that the denominator is increasing a lot more rapidly than the numerator. So this guy is definitely getting smaller, right? Each successive term is smaller than the next term. And you could put these decimals in and see that as well. All right, so we have this criteria met, check. So the next thing we need to do is we need to look at the limit as k approaches infinity. The limit as k approaches infinity of our a sub k. Actually, we're using n's here, so I'll go ahead and stick with the n's. The theorem is using the variable k, but my problem is using the variable n. So let's look at this. All right, is this approaching 0? All right, so this is equivalent to the limit as n approaches infinity of n over e to the n. And again, with the same kind of reasoning, we can see this numerator, or excuse me, this denominator is just going to get bigger and bigger and bigger. You know, the numerator is getting bigger too, but it's really only increasing by 1 each time. And so certainly we could say by the growth theorem, there's a growth theorem about what grows faster than other things. The bottom is growing a lot faster than the top here. So this is going to equal 0. All right, so that's met. So since those two conditions are met, then we can say that this guy, this series here, my alternating series, converges by the alternating series test. Okay, and you'd want to show, you know, this condition's met, this condition's met, we probably say is non-increasing. Now here I don't really care if it's approaching 0, but I can see that it is approaching 0. I can just see that each successive term is getting smaller and that they're going to approach 0. That's the second criteria. All right, let's look at another example, a little bit different. Does this series exist? Does this sum exist, I should say? So here we have a series. We're adding up an infinite number of terms. We can see it's an alternating series because each term is changing positive, negative, positive, negative. Does this sum exist? If it exists, then it converges. Right? If it's infinity, then it doesn't converge. If this is going to infinity or negative infinity. So let's take a look at our criteria. Criteria number 1. The terms of the series are non-increasing in magnitude. So let's just write our terms out, just the magnitudes, right? So we got 2, 3 halves, all right? That's 3 halves is definitely smaller than 2. The next one is 4 thirds, right? 4 thirds, that's like 1.3 bar, right? That's definitely smaller than 1.5. The next one is 5 fourths, that's 1.2. So that's getting smaller. What would the next one be? The numerator would be 6 and the denominator would be 5, right? Because this is 2, which is 2 over 1. So basically the numerator is increasing by 1 and the denominator is increasing by 1. Actually, sorry, this was 1.25, 1 and 1/4. This is 1 and 1/5, which is 1.2. And these are decreasing. So we could say that this is decreasing, which is, if it's decreasing, then it's non-increasing. Okay, so the terms are decreasing. Great, criteria 1 is met. Check. Let's go to criteria 2. What is the limit as k approaches infinity of a sub k? Well, we could write out a formula for this, and maybe we'll do that. But we could also just look at these terms here, and we could look at what is the limit of these terms. What are these terms approaching? What are they getting closer and closer to? Kind of looks like 1. Wouldn't you agree? I mean, there's going to be some term out here that's going to be like 101 over 100. That's pretty close to 1. And there's going to be 1,000,001 over 1,000,000. That's even closer to 1. Let's see if we can write a sequence here. Let's see. Well, let's go ahead and start at k. This is good practice too. If this would be a good idea to maybe stop the video and see if you can write a formula for this. I'm going to start at k equals 1, and we're going up to infinity. So I'm going to have my alternating business here, so I'll put in -1. Now I want my first term to be positive, so I'm going to have to go k plus 1. If I leave that as a k, I'm going to get a -1. So if I go k plus 1, or k minus 1 would work also, then that's going to make this first term positive, which is what I want. Okay, so now I need to get a 2 over 1 out of this. So how about we go k plus 1. If I start at 1, that's going to give me 2. And then I'll put k on the bottom. Does that look like it'll work? So if k equals 1, we're going to get 2 over 1. If k equals 2, we're going to get 3 over 2. And then if k equals 2, this will be to the third power, which will give me a negative. All right, so that means that my a sub k is this business right here. All right, so for condition 2, I could write the limit as k approaches infinity of a sub k, which is this stuff, and we have a rational function here where the degree of the numerator is equal to the degree of the denominator, and so we know that the limit, which is the horizontal asymptote of this thing, if you think of it as a function, is the quotient of the leading coefficients, which is 1 divided by 1, which is 1. So that limit is equal to 1. Uh-oh. My second criteria says that in order to determine that this guy converges, the limit has to equal 0. Sad face. Okay, so the second condition is not met. Does it mean it diverges? No, it does not mean that it diverges. It means that the alternating series test is inconclusive. All right, the alternating series test says that this guy converges provided these two things exist. It doesn't necessarily mean that it diverges. So unfortunately, we have to say that this test is alternating series test is inconclusive. And we'll probably have to use another test. Inconclusive. Maybe the limit test or the limit comparison test, the ratio test might work here. So we'll probably have to try something else. All right, hope that helps.